Good morning. Yeah, thanks for being on time. So let me share the screen. I hope you guys are able to see my screen.
Yes, Karthik.
Yeah, thanks. Okay, so quickly we discuss what we have learned yesterday. So we have learned deadlock. So can someone tell me what is a deadlock?
It's waiting on same resource.
Okay. So for example, if thread 1 is trying to, so thread 1 is executing one method and it is acquired the lock on object 1. And thread 2 is working on some other method and it has acquired the lock on object 2. And from the thread 1, from the object lock 1, and it is trying to access the object lock 2. And thread 2 is trying to access the object lock 1. So can I say this is a deadlock situation?
Yes.
Yeah. So now how to avoid the deadlock?
Proper order of the threads, thread
Not
execution.
threads. Yeah, lock synchronous. So whenever you're
Synchronized.
acquiring the lock, you need to acquire the lock in a same way. So whatever the objects, so throughout the threads, whether you write 2 threads, 3 threads, 4 threads, you need to write the proper line. When I say proper line in the sense, the first synchronized lock 1, synchronized lock 2. In other thread also you will be following the same. Okay. Now what is the other way to avoid the deadlock?
In sequence.
I could not understand. Can you come again?
Acquiring, calling. Yes.
Try lock.
Yeah. So in the lock mechanism, so whenever instead of directly calling the synchronized block and code, so synchronized block, whenever you call, so if there is a lock, it will go into wait mode. If there is no lock, it will execute. But whether it is going into a wait mode or executing, you do not know. Correct. So what we can do instead of using a synchronized block, we can use a lock mechanism, and you don't call the lock method directly. You instead of calling the lock method, call the try lock. What does the try lock will do? Try lock will check. If there is no lock, it will acquire the lock and it will return true. If there is a lock, it will return false. Correct. So that is how we can do it. And we also discussed about semaphore. What is a semaphore?
So giving the limit. So we are giving the priority to only some resources on the shared resources.
Yeah. So priority to a threads on this shared resource. Yeah. So whenever I create 5 threads and 5 threads are working on 5 different objects, can they work? Even though if the method is synchronized, I am creating 5 threads and these 5 threads I am passing a different objects. Can the 5 threads execute all the 5 synchronized methods at a time?
Yes.
Yeah. So, can I say that 5 threads have acquired the object lock on 5 different objects?
Yes.
Yeah. But the problem there is, so 5 different threads are acquiring the object lock. But if I want at a time, only 2 threads should execute. And remaining should go on to a wait. So then what I can say in the semaphore, we need to give number of permits. So a semaphore is a class in Java which takes one integer argument. Whatever the number that you do, can you say that at any point of time, only that number of threads will access the shared resource? Yes.
Yes.
So whatever the resource that you want to acquire the lock or should do, you don't need to write a synchronized block and all. Semaphore.acquire, semaphore.release, correct? Semaphore.acquire will make sure that then whatever the number that you have given, that many number of threads can execute into the acquire block and then release the block. Now, whenever you're using semaphore.acquire, semaphore.release, you don't need to worry about the synchronization because it is internally doing the synchronization, right? So this is a another one which we have discussed yesterday. Now let us look at today. Now let me write another package. I just created a join. Let me tell you join example. I have created a join. I created a class called join. So now in the Java, we have a join method, yield method, right? So I'm going to demonstrate what is a join method. Okay. Now, so instead of creating, if I want to create a thread, what I should do, create a class, implement a runnable interface, or extend a thread class. Instead that, can I create an anonymous in a class?
Yes.
Yes.
Yeah, thread t equal to, guys, first I started explaining the normal way. Later I am creating the difficulty. When I say difficulty, in the sense, whenever you look at any example over the internet or in your books or in your project, they don't separately create a class, implement a runnable interface and all. They will do anonymous inner classes or lambda expressions. So that's the reason I am writing those kind of things now. Thread t equal to new thread of, can I say new runnable? Yeah, can you say this is anonymous inner class?
Yes, sir.
Now, how this anonymous inner class we have implemented earlier?
We are creating separate class, and over the separate class we are implementing.
Yeah. So this anonymous inner class is same as creating a class, implement the runnable interface, override the run method. That's it. And that you need to create that thread t equal to new thread of that object here. That's it. And t dot start. Now, after that, I have hi. So now here, now here, whenever I debug the program, now I'll keep a debugger point in t dot start. Now, can I say directly these lines will be executed, or first it will come to this line and from here it will go here?
First start method will come, next run method will come.
Yeah. So whenever I write a anonymous inner class, it does not mean that it will execute, correct? Java is not a line number based execution, correct? Now, so if whenever first three, see, that means you are creating a thread object. Yes. On top of the thread object, you are calling start method. It will come here. And then start internally calls run method. So, and also it will create independent path of execution, correct? Now let me tell you. What happened? Yeah. So here, whenever I say thread t equal to new thread, I am trying to create an object of thread. But whenever you are trying to create an object, you need to pass runnable object to the thread class constructor. Now, instead of creating a class and implementing runnable interface, I'm creating an anonymous inner class. Okay. So this won't execute immediately. First it will go to the, look at here, t dot start. Whenever I say t dot start, it is responsible to create an independent path of execution. Now, for example, if I don't keep a breakpoint here, can I say that thread flow of execution?
No.
So whenever you are debugging, if you want to visualize a thread, you need to keep a debug breakpoint in the run method, because start method will create an independent path of execution and it will start the execution of that independent path from the run method. So now, so can I say that my say run thread 0 is started and it is executing? Yes. Now you can see one thing. So which thread, how does the thread get started? Can I say that main thread is a parent for this T thread, right? Main thread has created a T thread, correct? Can I call that main thread as a calling thread?
Yes,
which
sir.
has given the birth to another thread called T. Okay, now, so while your thread is executing 3.0, can I say that your main thread is also parallelly executing? Yes or no?
Yes.
So see here, currently I am running the thread 0 and main thread is also running. That means, can I say that two threads are parallelly running? Yes. Now, but in some scenarios, what I want, until this T thread is completed, I want main thread to wait. I repeat my question again. So I want, after the completion of T thread only, this line number 16 and 17 should execute. So line number 16 and 17 is executed by which method, which thread? Main thread, correct? Now, after the completion of a thread T, then only remaining work to be taken care by the main thread. Then how can I do? That's where the join method comes into picture. Now whenever you say T dot join, so then see it is giving you the interrupted exception. Okay. Now, whenever we say T dot join, what does it mean is, so who is the parent for this T?
Thread.
Main thread.
Main thread, right? So the parent of this T thread will wait until the T is completed, right? That means here, can I say that the parent of a T thread is main thread. So until the T thread is completed, main thread will go on to a wait mode. Now let us debug the same code. Earlier, you have seen while this method is executing, so this thread is executing, main method is also executing. Am I right?
Yes.
Now let us see the program. I just modified T dot join. See, can I say start method thread 0 is executing? Yes. Now what I will do? Now currently, where in which line I am there? I'm mentioning T dot join. That means after the completion of join method, then only the main thread will start executing. Now look at here, F6. If I do F6, so can I say the main method went into a wait mode? Am I right? Now when it
Yes.
will come back to the execution? So after the completion of a run method. Now let me complete this. Now can I say if I do F8, can I say that I have completed a run method? That means after the completion of run method, can I say that thread execution is completed? Yes. See, the thread is gone. Now look at here. Immediately main thread has come back to the execution of line number 17. Right? So what is a join method? So whenever you want to say that, for example, you want to do some calculation of, for example, if you take salary calculation. So first, in order to do the salary calculation, you have calculated a salary for 1,000 people. After that, calculated whatever the new salary that you are going to give for the next month. Can I say that you need to give it to the information to the bank, right? So you need to. So how do you give the information to the bank? You can each employee ID, name, and the new salary and the month. So that information you need to pass it to the bank, correct? And the bank will deposit that amount into the account. How do you pass that amount into the bank? So if it is a millions of record, then what you can do? You can create a text document, and you can keep that text document in the secured shared drive, right? Now, how can I create this? Creating a text document is one work, and calculating the salary of multiple employees is another work. So when the creation of a file should take place? After completion of a multi-threading. I mean, like salary calculation using a multi-threading. Am I right?
Yes.
So, for example, you are one of the thread is doing the salary calculation. Now, in another thread, it has to do the file calculation, file creation. Now, can I say that T dot join means the main thread? See here, let us create another thread which is responsible to create file creation. Okay. Now, assume that in the T1, in the run method, I'm creating a file execution. So, file preparation. The prerequisite for the file preparation is your salary should be calculated, correct? Now,
Yes.
can I say now whether T thread or T1 thread, who will be starting? Main thread only, correct? So from the main method, you are starting. So what you need to do, you are telling t dot start and t dot join. That means main thread will wait until the t is completed, and then it will look at the t1 code, and then can I say t1 dot start? Then second thread will execute, correct? So this is the best example when you can go for a join method. So what is the join method will do? Whenever you say t1 dot join or t dot join, so join method is it a static method, guys? It's not a static method. Look at here, I'm using an object, not a class name, correct? So this join method is present in the thread class. And what is the use of a join method? Whenever we say thread object followed by the join method, so the parent thread which has created the created a execution of the thread will go into a wait mode, and it will come back to the execution after the completion of a thread, right? So that is a use of a join method. So that means if you want some process to be executed after the brief, you have a dependency. First, I want to execute one process or one calculation. After that calculation only, I want to trigger the second calculation. So there is a dependency. Whenever you have a dependency, you cannot do the multi-thread. I mean, like multiple tasking, right? So what you have to do, second process has to wait for the first process. Now, how can I make sure that after triggering the first process, you have to say t dot join? Then your main thread will go into a wait mode, and it will come back to the execution after the first process is completed. Then you can trigger the second process. Does it make sense? Okay.
Yes, Karthik.
Yeah. So now this is good. But here, whenever we are doing the multi-threading, did we use, whenever we are doing that executive framework and all, did we use a thread? Like a normal way of creation, thread to equal to new thread? In executive framework, how did we create a thread object?
By using submit method or execute method.
Okay. Now that means, now can I say that here, if it is a normal way of thread creation, you are calling the join method in a thread object. But in an executive framework, how can I do? Correct? In the executive framework, are you triggering so here, whenever you call join method, how many threads are going into a wait mode? So main thread is waiting for the one thread to complete the execution, correct? At a time, so using the join method at a time, you can wait for one thread to complete, right? But in the multi-threading, whenever you are using a executive framework, can I say that you are using a thread pool? Yes or no?
Yes.
Yes.
Whenever you are using a thread pool, how many threads will be there in the thread pool? Is it a single or multiple?
Multiple.
Multiple.
Okay. Whenever multiple threads are there, after the completion of all the threads execution, then only your other trigger should work. Now let me take another example. Thread join for multiple threads. So for example, thread main method. Now, so how can I create an executive framework? How can I create a new fixed thread pool?
Executed start new fixed pool.
Yeah.
It will return the executed service also.
So I have to give 3 threads. That means, can I say that I am creating a 3 threads?
Yes.
Yeah. So executed service, it will return EX. Okay, done. Can I say now here, earlier you are doing thread to T equal to new thread. But in the executive framework, whenever I'm using executive framework, do I need to use thread to T equal to new thread?
No.
Okay. Now, how can I make sure that, so now here, how can I create an independent path of execution whenever I'm using a executor service or executive framework?
ex.submit or execute.
ex.submit or execute method. Okay. Now, what does the execute method or submit method will take? Execute method is taking a runnable object, correct? So execute method in the executor service interface is taking runnable object. Now, what I have done whenever I'm showing you the multi-threading program, I have created one trigger email for trigger email one class, and which is implementing a runnable interface or callable interface. And that object I passed here. Am I right?
Yes, yes, got it.
Okay. Now, instead that, can I create directly an anonymous inner class here itself?
Yes.
Correct? Now, so here let us create. So can I say anonymous inner class? Can I, so here it is expecting runnable. So can I say new runnable? Correct? So this is also thread flow of execution, correct? Multi-threading.
Yes.
Okay. Now here, now whenever, so now let's say, now can I say this is nothing but, so I'm creating a thread pool. Now, so can I say this is a executor framework and the 3 threads will say here, let me keep instead of r.length, let me keep 10. How many times this for loop will be repeated? 10 times. How many times this, how many threads I am creating? Only 3 threads. And these 3 threads will continuously taking the work of these 10 tasks, correct?
Yes.
Okay. Now, after, see here, how many threads are you're making? In this process from line number 10 to,
10.
So 21. So we are creating a 3 threads only, but those 3 threads are able to perform the 10 tasks.
10 tasks.
Am I right? Yeah. So can I say the difference between earlier program and this program is, in this program, how many threads are there? Only 1 thread. So on top of the thread, you are calling a start method, which will create a independent path of execution. And then whenever you call a join method, this thread, so main method is waiting for this single thread to complete, correct?
Yes.
Okay. Now, if I want, similarly, in this one, I want to use a join functionality. That means I want the main thread to be, see, after see here, no, if I write system.out.println, can I say while these threads executors are executing this pools, can I say main thread will execute these lines, this number of lines, correct?
Yes.
It will execute parallelly, correct? But
Yes.
I want the join method. See, whenever I'm using a join method here, I use a thread object. But do I have a thread object here? No, I have used to execute a framework, correct? So I do not have an explicit thread object, right? Now, I want to make main thread to execute after these 3 threads have been completed. The first difference you need to understand here is, in the earlier program, I have 1 thread. So whenever we say t.join, so the thread which is started, the main thread will go on to a wait mode until this is completed. But here in this process, I do not have 1 thread. I have multiple threads. Then I want my main thread to wait until this thread is completed. Now, can I call the join method here like this? Can I keep join? Now I can keep. But what is the thread object? You tell me, correct? Do you have a thread object?
No.
It is created automatically, correct? Internally, right?
Yes.
This execute method itself will see, whenever I say new fixed thread pool, it will create a 3 thread objects. On top of the thread objects, it will call the execute method, correct? So that is all taken care internally. But here I want to use a join functionality. That means I want my main method to execute only after completion of this, all the threads, correct? Can I say this is a join functionality? So whatever the plain join functionality that is there in the threads, can I implement that directly to a threads executor framework?
No.
No. Can I say you understand the drawback of a join method, right? So join method will make the current only 1 thread to. So whenever you are using a join method, the calling thread will go on to a wait mode until that single thread is completed the execution. But whenever we are using a multi-threading programming, there may be multiple threads. Now let us show you this one. So I have not written anything. Let us show you first. Main thread is executing parallelly or not. Okay. See, 1 thread has created. See, execute method is responsible to create multiple threads, correct?
Yes.
Can I say 3 threads have created?
Yes.
Yeah. Now look at here. my main method is also there. Like 3 threads, can I say 3 threads are executing parallelly? Yes. But at the same time, your main thread is also executing, correct? For example, you see here in this executor framework, you are assuming you are creating a, here in the run method, you are writing a calculation of salary. Okay. This is the logic you are writing. After this one, after these threads are completed, then here you want to create one more executor framework to or single thread process to generate a file. But here your main thread is waiting for the threads to complete? No. That means there is a mistake. Now that means your program, see here, this generation file can be continued parallelly and it will generate an empty file, correct? Because your threads are busy. It has not computed the salary calculation. Now, can I say in this scenario, your main thread is executing parallelly. Now you need to stop main thread and wait until all these three thread pool threads are completed. Am I right? So that is nothing but a join functionality. So if you want to do this, if you want to make the main thread to wait until all the threads are completed or until multiple threads are completed, then you need to go for countdown latch. So there is a very concept called as a countdown latch. Now let me show you how. So countdown latch, there is a class C equal to new countdown latch. Okay. Now you need to give how many countdown latch will take the number. So here, how many tasks you are performing? 3 threads
10.
you have created. How many?
10 tasks.
10 tasks. So now whenever you say here, in the run method, what you need to do, C dot count down. Let me make it as a static.
Sir, can you repeat
Yeah.
why we need this countdown latch? I mean,
So here in the join method, what is happening? You tell me.
it's waiting for main thread.
Yeah. So here, if you
Sorry,
don't write this join method,
Mhm.
so while the thread, this thread is executing the run method, your main thread will execute this code also, correct?
Yes.
But my scenario is I have a task 1.
Mhm.
Okay. So let me draw that here. So I have a task 1. Someone T1 should execute one work. Okay.
Okay.
After completion of this work, after completion of this, T2 should execute another work. Okay, this is my
Yes.
use case.
Mhm.
Now in this use case, how do you trigger T1? From main method, correct?
Yes.
So in the main method, first you write T1 dot start. Can I say it will trigger the independent path of execution?
Yes.
After that, you will write T2 dot start. If you
Yes.
write this code, does it mean that T1 and T2 are, see, T2 is waiting for T1?
No.
It can execute parallelly, correct?
Yes.
Because your main thread will start this process. After that, immediately it will go here. Now, what you want to main thread? You want the main thread to complete this process and then only trigger the second one, correct? Now,
Yes.
in order to do that, what I will do, if I say between these two lines, what I will do, so that means T2 thread can start only after the completion of T1, correct?
Yes.
So who is starting the T2 or T1? Main.
Main.
So
Yeah.
if I say the T1 dot join, what will happen? So first it will start the T1 and then main method is looking at the join method. That means the main thread will go into a wait mode until the T1 is completed and then T2 will start, correct?
Yeah. For join method, always
Yeah.
main thread is waiting. Right.
Yes. Now the same thing. Now this is now here in this scenario, main thread is waiting for how many threads to complete?
One thread T2.
Only one thread, T1, correct?
Yeah.
Main
Yes.
thread is waiting
Sorry.
for the T1 to complete. Done.
Yes.
Now, here this is a normal plain threading technique, correct? Now, what I will do is instead of plain threading technique, I want to use multiple threads or executor framework. Whenever I use the executor framework, can I say I can use a fixed thread pool?
Yes.
So here in the fixed thread pool, I will give 3. What does it mean?
It will create 3 thread.
3 threads. Now, do you say whenever you say execute a framework, do you use T1 dot start, T2 dot start, T3 dot start like that?
No.
We automatically execute or dot execute method will take care, correct?
Yes.
Now, here, how many, whenever you say in the main method, how many threads are there? 3 threads are executing, correct?
Yes.
Now, can you use the join method in the multi-threading, correct? Now, what you
Yes.
want, see, after completion of a earlier scenario, you have only one T1 thread. But now what I'm doing, since I'm using an executive framework, I have a group of threads. It can be 3, 4, 5, 10.
Okay.
So after completion of this number of threads, I want to go to this process, correct?
Okay.
Now, can I use join method in this scenario?
No.
No, because you have multiple threads. So join method can be, using the join method, how many threads you can, the main thread can wait? Only one thread, correct?
Yes. Yes.
So, but here in the executive framework, you have multiple threads. How can I do? That's where you go for a countdown latch.
Okay.
Hope you understand.
Yes.
Now, countdown latch is a class. Now, yeah. So countdown latch is a class. Look at here. And so here, that means I have to wait until this 10 tasks to be completed by 3 threads, correct? Now I am initializing the countdown to 10. Now here, so every time the thread is, see what will happen here? Can I say that 3 threads will be created? These 3 threads will take the work like this, correct? T1, T2, T3, and from the queue 0,
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, correct? Okay. T1 will take this, T2 will take this, T3 will take this. That means it is taking the means. Can I say that it is executing run method first? Yes.
Yes.
After completion of T1 again, it will take another work and it will execute the run method only, correct?
Yeah.
So whenever it is executing, so I have initialized the countdown latch to 10. So this 10 should be number of tasks that you want to complete. So whenever you complete the countdown, initially 10. So after completion of one thread, run method, it will make it to 9, 8, 10, 7, 6, 5, 4, 3, 2, 1. As soon as the thread is completed, that this count will be reduced. Okay. And
Okay.
then, so here in the main thread, instead of this T dot join, so C dot await. There is a method called await. So this method you need to use. This method makes, so this method will know whether all the threads have been completed or not based on the countdown. If the countdown value is 0, then the lock will be released. Let me run this program. Hope you understand.
Yes.
Okay. The drawback of a join method is join method cannot be used in the executive framework because we have multiple threads, correct?
Yes. And we don't have control.
Yeah. See, can I say 3 threads are executing?
Yes.
Now let me go to the main thread. So if you look at here, see all the tasks are submitted to the queue, correct?
Yes.
Yes.
Now earlier without this await method, you see, earlier am I able to, the main thread is able to run this system.out.println?
Yes.
Okay, but here assume that here in this multi-threading I am creating a salary, and here I want to run a generate file. So generate file has a dependency of salary calculation. Am I right?
Yes.
So that means, can I say that all these threads has to be completed before triggering the salary calculation, correct? Sorry, generating a file, correct?
Fine.
Now, earlier without this join method or await method, the main thread is executing. Now you look at here. Now, if I do F6, see, can I say that my main method is not executing at it went into a wait mode?
Yes.
Now, when it will come back to the execution, whenever all the tasks are completed, how does the Java knows that all the tasks are completed? Look at here. What is the countdown latch you are given? 10. So, and you are executing number of tasks at 10. So every time it will say after completion of run method, at the end you need to put count down. That means the number will be reduced. Whenever the number becomes 0, the await will release the log. Now let's look at here. See, can I say 1? See, you constantly, when I do the F8, you constantly look at that main method. If it is executing, can I say that it will show the suspended some later, correct? If it is a waiting, it will show stepping, correct?
Yes.
Now look at here. See, I'm doing F8. That means one thread is completed, done. See? See, thread 2. Now, can I say if now only how many threads are remaining? Only one task is remaining, that is done by the thread 3. Now, if I do F8, see, look at here, it has come back, the main thread, correct? That means, so am I doing the same work here? Can I say that I am waiting for multiple threads to complete all the tasks, correct? And then this second thread should take the place. Am I right?
Yes.
So if you want to do the join kind of a functionality in a multi-threading, you need to go for a countdown latch. Countdown latch will make sure that all multiple threads are completed before you trigger the other task, other work.
Yeah, it's similar to join. I mean,
Yeah. So now you want to see, whenever you say c.await, you want to see the count. Then what is the count? See, get count, it will give you 0. You just need to print it. Okay.
okay.
So how does the countdown latch works internally is, so whenever you are executing the work, the countdown, the number will be reduced. So how many, so generally here your question might be, sir, how should I initialize this value? This value should be number of tasks you are executing, correct? Now each thread will execute this task, and task means it will execute a run method, correct? So the number of tasks that you are mentioning here, I can say if you mention the same thing, whenever the countdown is 0, what does it mean? You have created some n number of threads. That n number of threads have completed all the tasks. And after that, you want to trigger another one. So this is about a countdown latch. Any question? Okay.
Implementation. Countdown.
I could not hear you properly.
Can you show the implementation, maybe class countdown latch?
It's a class, general class. Yeah.
Okay. Yeah.
Normal class in Java. It does not have a lot of code also. It is introduced in 1.5.
Okay.
Okay. No. So that is what I told. How does the await method will release the lock is based on the 0. The count is 0, it will release the lock. Whenever if only 5 tasks are executed, what is the countdown? It will contain 5. So countdown means initially 10. As long as the tasks are completed, it will reduce the count. And whenever it is 0, it will release the lock. That is what there in the code. So whenever it is 0, it might be doing the notify method on the main thread, so that main thread will come back to the execution. Okay. Now let me tell you. So see, for example, I want to. Okay. Now here we know the synchronization. Without synchronization, what happens, guys?
We use without synchronization, data may be incorrect data will be found.
Okay. Okay. Now I'm creating another package. Let me create a class. Okay. Main method. Now, so let me take one static variable, static int count. Okay. Thread t equal to new thread. New runnable. So here, count plus plus. Okay. Now can I say what is the code I have written, guys? What is the meaning of this?
We have created one thread.
And it is in the run method, I'm just incrementing the count, correct?
Yes.
Now can I do one more thread also?
Yes, we can do.
T1. In the another thread also, I'm using the same variable, correct?
Yes.
Okay. And then T1 dot start. Now can I say that two threads are say do I have any synchronized code here?
No.
No.
Okay. Now, see this out. So after the completion, now let me write here for, I want to repeat this count plus for internally one block. Okay. Now if I keep like this, okay. Now I have any synchronized block?
No.
No. That means, can I say that multiple threads can execute multiple? See here, this count variable can be accessed by both the threads at a time. Correct?
Yes, yes.
So generally, whenever one thread is, say, for example, T1 thread, T2 thread, can see the count variable 0 first. Correct? And it is doing some operation, count equal to count plus, it is executing for loop. And it is also executing for loop. Can T2 see what is the value of count in the T1?
No.
Because threads are independent path of execution. At the same time, T2 cannot see, correct? Now, ideally, if it is seeing, what is the output you expect? After completion of 2 threads, if I print count here in the main
2000.
method, 2000, correct? Here 1000 times it is getting repeated, 1000 times. So plus means, can I say that 2000? Yes or no?
Yes, yes.
Yes.
Everyone. Okay. Now let us run the program and see. See, if you debug the program, it is difficult. Now let us run the program. Why it is not happening? Okay, just a minute. Just give me a minute, guys.
Volatile, we haven't keep.
No, that doesn't matter. I'll come to the volatile later. I just wanted to see what is the difference I have written.
So it might be before going to thread 1, thread 2, the main thread will be complete.
Yeah. Okay, let's keep T1 dot join T2 dot no. So T dot join. Let us see. If not, we will see the other program. But the main idea is I'm not using a synchronized block. If the synchronized block, if I'm using, then no issues. Correct? Run as Java application.
Yes.
So here I'm waiting for the thread to complete. So it is taking. Now let us remove this one. Okay. So let me go back to the another example that I have written. Let us see that program. Both are same. Some mistake we have done. So instead of researching on that, what mistake, let's go to that program. Okay. Now, so here, this is also same. So I just, instead of writing the like run method, what does it mean? Can I say this is a lambda expression for a run method?
Yes.
Yes.
Okay, now remove, let us not use a volatile variable also. So T1 thread, so I'm just writing the implementation using a, what you call lambda, okay? Now here also same thing. So count equal to count plus I'm doing, okay? Now, I have started T1 dot start, T2 dot start. Okay. Yeah. So T1 dot join, T2 dot join. Now let us run the program and see. See, do you guys see the output is coming? See, currently 2000.
Yes, sir. One of the time 1268 came.
Yeah. So that means it may be 2000 or some other number, right? Let's continuously execute. See, 1795, 1930, 1260, 1263. Why is this happening? If it is having a sync, then can I say my output should come 2000?
Yes.
So guys, look at here carefully. Two threads are there. So in the two threads, I have written a for loop. Now, what is the what? See, when I say count plus plus, what does it mean? Count equal to count plus 1, correct? Count equal to count
Plus
plus
1.
1. Here also count equal to count plus 1. Okay. Now, for example, if each thread is, for example, what is the count value for starting 0? Now, when for I equal to 0, I less than 1000, I plus plus. Now, what will happen? First 0. Here 0 plus 1, the count has become 1. And then if it is seen by the other thread, 1 plus 1, it will become 2. If it is seen by here, 2 plus 1, 3. Likewise, after completion of these 1000 repetitions, here also 1000. Can I say my count value will be 2000?
Yes.
Yes. Okay. Now here, but here sometimes you are getting output as 2000, sometimes 1263. Why am I getting 1263? Can I say the problem here is whatever the count that is happening in the T2, T1, that is not able to seen by the T2, correct? Because T1 is an independent path of execution, T2 is an independent path of execution, correct? Am I right?
Yes.
And here, can I say I do not have a synchronized block? If I have a synchronized block, at a time only one thread can execute. Then no issues, correct? If I add a synchronized block, only one thread, see, both are working on the same object. So at a time, only one thread can execute. I don't have a problem. Always the count will give me 2000, correct? But the problem with a synchronized block is, can I say your time will be increased? Performance issue, correct? Yes or no? So if I use synchronized block, when T1 is executing this code, can I say it will acquire the lock?
Yes.
At the same time, T2 thread cannot execute this method on the same object, correct? Now I can solve this problem using a synchronized, but I don't, so just for the sake of getting the variable count, I don't want to make it as a synchronized. Then how can I resolve this problem? The problem here is the count should be 2000, but sometimes I'm getting 2000, sometimes some other number, correct? Now if I execute again, see 1838. Is this a desirable whenever you write this program in the run application? See, continuously you get 2000 something, see 1686. Sometimes 2000, sometimes different numbers. Are you guys see? See 1703. So can I say it is behaving differently?
Yes.
So can I say this is a problem?
Yes, yes.
In order to solve this problem, what you have to do, you have to introduce a synchronized block or synchronized method or lock mechanism, right? Or semaphore. Anything you can use. But if you use this, what is the problem? Whether it's a lock mechanism or synchronized, when one lock is there on the same object, can other thread should wait.
Has
correct?
to wait.
Yeah.
Yes.
So if it is waiting, it will give you the accurate output, but your time taken by the program might increase. Correct?
Yes.
So and like that, you can go to that whenever you are doing a big like lot of logic. But this is a just variable increment or something you want to do, then you don't need to go for that. That's where the atomicity comes into picture. So in Java, there are some variables called atomic variables, atomic integer, atomic double. So look at here. So there is a class called atomic integer. Similarly, if you look at here, java.util.concurrent.atomic. This is the package. In this one, you have atomic long, atomic reference, atomic double long, double also will be. Yeah, double is not, sorry. Atomic Boolean, yeah, atomic Boolean. So these are the classes which you can use it. Even though you do not have a multi-threading, so if you use this class, the output will be accurate. That means, see, at any point of time, even if you are not doing the synchronized block, what this atomicity will make sure that only one thread will work, and immediately the change will be applicable, shown to the other thread. That means it will do the compound operation at the same time, show that value to the other thread. Now let me comment this and enable this one. See, atomic integer is a class. For that atomic, and I'm creating an object. I'm using count variable. Now you want to do plus plus. In order to do the plus plus, we have a method called increment and get. Increment and get will do internally same thing, plus plus. See, look at here. Get and int, add int. That means whatever the value is there, on top of that you are adding 1. Is it same as plus plus only? Correct? Now similarly, let me do in this one also. Instead of using a normal variable and synchronized block, you can go for atomic variables. Atomicity is nothing but on top of a variable, you can make sure that only one thread will work at a time without a synchronized block, and that updated value will be available for another thread. Okay. Now you execute any number of times, the value will be 2000 only. Now let us see. Say 2000. Am I executing? Do you see any other value?
No.
It is giving, see, earlier program also executed multiple times. Sometimes I got the 2000, sometimes I got some other number. But if I execute this process, look at almost 20 times I executed. But what is the value? Always it is showing 2000, correct? That means, can I say my thread output is proper?
Yes.
Yeah. So this is nothing but an atomicity in Java. So atomicity is nothing but at any point of time, only one thread can execute without having a synchronized block or lock mechanism or semaphore, anything. I will give you the notes, all of this one. Yeah, in multi-threading program, it is possible for multiple threads to access the modify the same variable concurrently. Correct? This is what we have seen, correct? Without, in this program, if I comment this line and if I uncomment this line, can I say this, whatever the statement I have read, that is true?
Yes.
So now if I uncomment, look at here. In multi-threading programming, it is possible for multiple threads to access the and modify the same variable concurrently. Now, see, here this is one thread and this is one thread. Are these threads are using same variable? Yes. And is it modifying the value plus plus means concurrently? Yes. Now this is the problem. When multiple threads modify a variable concurrently, there is a possibility of data race. Data race is nothing but data is. So there is a something called as a race condition. I will explain that. We already discussed what is a race condition, but in a different way, I will explain that in the interview questions, which can result in incorrect or unpredictable behavior of a program. Can I say this statement is right? So incorrect
Yes.
result, that sometimes it is giving 2000, sometimes 1700, sometimes 1203, sometimes different. To avoid the data races, we need a way to ensure that variable is accessed and modified atomically by a single thread at a time. What is atomically? It is by a single thread at a time. This is where the atomic variables comes in. Atomic variable provide a way to modify variable atomically without need for locks or other synchronized mechanisms. You understand here, right? If you use a synchronized mechanism, so entire block of code you need to be synchronizing. But here, am I doing anything? Correct? No. Only just a variable you want to get it, even though multiple threads are working and there is no lock kind of a behavior, but still you want to achieve atomicity. Then you go for atomic variables. Any questions?
Karthik, can we use regular arithmetic operations on atomic variables?
Yeah, so that so increment and get, there are some methods. So
No,
only
like
those
count
methods
equal
you can
to count
use.
plus 1, can I write it?
You know that in order to do that, you have to use this method, increment and get.
So let's say I want
Increment.
to I want to reduce. I want to do other arithmetic operations like
Yeah, decrement and get.
plus 3 plus minus 3 like that.
Look at here, add and get. You can give the data here. See, count equal to count plus 3 you want to do, correct?
Yeah.
So add and get, there is a value. So in this one, in this class, you have methods. Look at here. Get an increment, get an increment, get an add int. So here, get an add int will give you are passing the data, correct? So count equal to count plus 3. Then what will you do? You call the method get and add and you pass 3. Okay.
Okay. Divided by and all we can do.
Yeah. So you whatever the methods are available, you can do those.
Okay. Fine. Second thing, how is it different from volatile? Volatile also maintains.
Yeah, volatile. Yeah, volatile will make sure that visibility problem, correct? But here compound problem is there, right? Now let's keep the variable. Now let us comment this code. Let's make this variable as a volatile, correct? Now, so here volatile will solve the problem of visibility, correct? So when one thread is doing work, now let us execute. So can I say that I have made the, see here, we are assuming that problem is only the visibility, correct? Now that means whatever the thread one is doing the variable for count, it is not shown by the count another thread. That is a visibility problem. So volatile will solve the visibility problem. But still, if I run the program, if I am getting the output sometimes as other than 2000, can I say that still problem exists? Correct? So that problem is because of this operation, read and write operation, right? See, whenever I say count equal to count plus 1, count plus plus, what does it mean? Count equal to count, you are reading and then writing. Can I say that two operations are present?
Right.
So the volatile will solve the visibility problem only, but this kind of a read and write problem will not be solved by volatile. Now let us run the program. So, and see whether the count, at least if I'll run 15 to 20 times, at least one time, if I get an output other than 2000, can I say the problem still exists even if I'm using a volatile?
Right.
Yeah, now let us do. See, 1181, 2000, 2000. Once I got 11, see, 1692. That means still, that means volatile has up to some extent, it has provided the visibility problem. But see, once you are doing the visibility, at the same time, the variable is getting added, correct? By the time, what is the meaning here is, by the time you are doing the operation.
You mean volatile is not blocking, but atomic.
No, volatile will not block, or it will not, volatile will not make sure that only single thread operation. No. Whatever is happening for the count variable in this one, it will push it to the main memory. Immediately thread 2 can see it. That means volatile is solving the visibility problem. But here, when, see here, for example, count is happened 1, here also 1 can be seen, okay? But at the same time, here the compound operation is happening. Here also it is happening, correct? Hope you understand.
Yes.
Though it is having the same memory, at the same time, multiple threads are modifying the value. Still, the value will not be updated, right?
Yes.
So that is the issue.
It is like a synchronization at variable level.
Yes. So that means if you use a synchronized block, all these are not required.
No, not at block level, at variable level, maybe at increment level.
If, for example, if you are writing synchronized block only for this variable like this, then you don't need to worry about atomic variables and all. But whenever you are using a synchronized block, what happens again, like time consuming, correct? So if I want to overcome I don't want to write just for this purpose, then so that means in any multi-threading, if you do not have a synchronized mechanism or lock mechanism, but you want the output or variable to be synchronized properly, then you can go for atomic variables. So what the atomic variables will do, even though you do not have a lock or synchronized mechanism, it will make sure that at a time, one thread will perform the value and then other thread will have the latest value.
Okay, got it.
And you need to remember that volatile will solve the visibility problem because we know that threads are independent path of execution. One thread cannot see what is happening in another thread. Agree?
Right.
So in order to solve that problem, we go for a visibility. So volatile. Volatile, what it will solve? Volatile will solve the visibility problem. But in this code, apart from the visibility, there is a problem of compounding, reading and writing operation. So,
Right.
so that requires additional layer. So that additional layer is provided by the atomic variables.
Got it.
Yeah. So I have mentioned that also in the notes. If you once you go through, I have not shared this one. I will share it by tomorrow. In the notes, I have clearly mentioned how it is different. I have added a question also. Difference between volatile and atomic variables. Look at here. In the summary, both volatile and atomic provide the same safety of thread safety. Atomic variables provide stronger guarantee that thread safety by ensuring both visibility and atomicity. But only volatile will provide only visibility issue, solve the visibility issue, but atomic variables will provide solve the visibility issue at the same time atomicity. Atomicity means only one thread can execute at a time. So look at here. Atomicity, the definition over here. Atomically, that means single thread at a time. Okay. Any questions?
Sir, in this static keyword also doing same the job. Yeah.
But still, that is what, even the static is there. So it is not getting solved the problem, right?
If I don't put volatile keyword, it will share the data, right?
No, that is what you can see the value, right? How it, see, static variables, memory will be acquired at least only once, but that is not getting updated, correct? That is a problem. Look at here. Without this also, if I run the program, see, 1687, 1740. That means, is the problem solved?
Problem is not solved, but volatile keyword, static keyword doing
No.
job both are same.
No, static keyword will acquire the memory in the Java stack, but volatile will not take any memory, correct?
Yes.
Volatile will make sure that the visibility problem between the threads will be resolved. These two are different. Static you can write for a variable and a method, but volatile you cannot write for a method. Volatile you can write for a variable only.
So filter asks what is the difference between static and volatile?
Volatile can be used for non-static, and see, static does not belong to a thread first of all. Stack area, Java stack is there, right?
Yes.
So in the Java stack, the memory will be allocated for static variables. Okay. Volatile is not a memory. Volatile will make sure that if multiple threads are using the same variable, that variable will be immediately reflected to other thread. That means it will solve the visibility issue. Volatile will not create any memory. So static belongs to static block will be executed, or static code will be executed during the class load time itself. Volatile will be at runtime. Hope you get it. Okay. Now let us quickly, I'll take another 15 minutes, guys, and solve the producer consumer problem. Okay. Will that be fine if I take another 15 minutes?
Yes, Karthik.
Actually, I have another class.
Okay. Is it possible for you to
maybe
look at the
yes.
Yeah. Only anyways, I will be reporting that in the tomorrow class.
Okay.
If you are okay, then you can continue. If not, then okay. So this producer consumer is why am I explaining this producer consumer? So in the thread executor framework, did I show you that internally it is using queue, specifically blocking queue, correct? Okay. Now, can someone tell me what is a queue in Java?
We use an interface in Java, and we have some couple of classes in there to provide the implementation. We use it for like first in first out operations. We can use the queue.
Okay. So queue is a class in Java which can be used to perform the first in first out. Okay. So this is a data structure topic, guys, but still I'm explaining because internally you have seen somewhere the queue. Okay. Now, so here, so if just queue is nothing but first in first out. What is the meaning of first in first out? Whenever you are getting into a bus, there is a statement saying that please form a queue. That means whoever is standing first near the door can I say that that person will get into the bus first? Right? Now, if I take an array, this is the index position 0, 1, 2, 3, 4, 5. If I say add, which first time add, second time add, third time add. So this element, which element will go to 10 will go where? Guys, if I say the data, how this data will be added to the queue?
Then we'll go 0 position. 20.
Like this, correct? Now in this one, which is the first element added?
10.
So that means first in, first out. What does it mean? Whenever I do the deletion, can you say 10 will come out first?
Yes.
Yeah. So now q dot add 10. $50. Okay. Now if I do that, so in order to delete first in, first out in the queue, there is a method called poll. What does the poll method will do? It will remove the head of the queue and it will return the value. So here, what is the head of the queue? Head of the queue is nothing but 0th position. So it will return 10 and it will delete 10 from the this data structure. And then 20 will be there. 20 will come here. 40, 50 will come here. Right? So now let us see. Now if I do the queue poll method continuously, it will return, say, look at here. Out of this data, 10 is the first element added. Second, 20. Okay, let me add only 3. Okay. Now what is the first added? 10, 20, 30. The output also 10, 20, 30. So this, in this way, I can tell that this is a this is following a queue. See, output is 10, 20, 30. Right? So this is about a general queue. Now I have mentioned here array blocking queue. The size is 3. Now let me try to add fourth element. Generally in the collection framework, what is the advantage of collection framework?
It's resizable.
Okay, but let's look at here. See, is it resizable? In the there is a class called array blocking queue specifically. Whenever you are using a add method, beyond this size you cannot add it. That is a problem. Okay. Now, if you look at here the blocking queue. So in the array blocking queue, there are some methods called put method and take method. Now let me, if you are instead of using a add method, if you are using a put method and take method, then it can take. I mean, it will not show you this validation. Okay. Now let's do the same program with different threads. So what I will do is, I will create a thread. Okay. Or let's go quickly. Okay. I'm just saying thread 1 extends thread run method. Now here I will say, so I want to take an object. That means I want to see both the threads are working on same object. So I will accept the let me take it as a blocking queue. So there is a blocking queue with an interface in Java which extends from queue interface. Okay. So this is same as multi-threading example only, guys. So in the multi-threading example, in the constructor, what am I doing? I'm taking a HDFC bank object, correct? Now instead of HDFC bank object, I'm taking blocking queue object. In this blocking queue, what I will do for in the run method, I'm using 4, then Q dot put. I'm calling the Q dot put, and then I'm adding I. So that means, can I say how many times this put method will execute? 4 times, correct? Now,
Yes.
yeah. Now let me create another thread. Let's make it as a thread 2. Yeah. So in the thread 2 also, I wanted to do the same thing. Only the change is, instead of take put method, I will call the, I don't need this one. I'll call the Q dot take. This take method is nothing but a poll method. Like it will delete the element from the queue. So look at here. Retrieves and removes the head of the queue represented by the TQ. Okay. So now it is deleting. Let me put the sys out. Okay. Now. Okay.
Remove, yeah. Remove line number 15.
Okay. One extra breaks. Okay, fine. Okay, fine. Still the error? No. Let me go to the producer consumer problem. Now here I am creating those thread. Thread 1 equal to new thread 1. That means I am creating a thread 1 object. Now what does the thread 1 will take? Blocking queue, right? Blocking queue. Queue equal to new array blocking queue. Okay. What is the capacity? Earlier I have mentioned 3. I'm also giving the 3, and I am trying to see whether it will give me the queue dot full error message or not. Okay.
So we have taken in the implementation thread class array DQ.
Yeah. The error is gone. I don't know why it is showing. Yeah, gone. Now let me create a T2 also. Now can I say both the threads are working same object now? Right? Yes or no? Did I write any synchronized block? No.
No.
So the take and these methods will do the synchronization internally. Now can I say T1 dot start, T2 dot start? Yes. Now can I say both the threads will start?
Yes.
Okay. Now let's start the thread. So I did not mention anything about synchronized block, correct? Both the threads are working on a same object without synchronized method. Can I say that both the threads can execute parallelly?
Yes.
Yeah. So now 2 threads started. Now first thread, let us see. See, whenever, what is the size of the queue? 3. So just now we have seen whenever the size is 3, if I am trying to add the 4th element, does it given me the error? Queue is full?
Yes.
Yeah. Yeah. In the earlier program. Now let us see whether I will get that error or not. Only the change is, instead of using the add method, I'm using a put method. This put method internally uses a thread concept, like wait, notify concept, and it will wait. Look at here. Now, first element, I'm adding it to the queue, correct? See, what is the queue? Currently, it is having 0. That means I am adding E. That means, see, second element, my queue size is 2. Okay, done. Now, whenever I add the third element, can I say my queue is full? From the main
Yes.
method, what is my queue size? 3.
3.
Now, if I try to add the fourth element using a add method, can I say, did I get an error saying that my
Queue is
queue
full.
is full? But now let us see the same program. Now, whenever I try to add the fourth element, am I getting any exception? No. Can I say that my thread is into a wait mode? Correct?
Yes.
Did I write the synchronized block? Did I
No.
write the lock mechanism?
No.
No. That means why see this put method internally uses a synchronized or locking mechanism and wait, sleep, notify like a concept. What happens is now, so whenever why the thread went into a wait mode? Because your queue size is full. There is no size, there is no place to insert a new element. Am I right? Yes, or no?
Sir. Yes,
When
yes.
this thread 0 will come back to the execution when there is a place, correct?
Yes.
Now, how can I create a place? Can I execute the thread 1? So, sorry, my mistake. In the thread 1, what I am doing? I am deleting the data, right? Using the take method, right? Okay. Now, let us execute. So here, the put method and take method internally does the synchronization, locking, wait, like that. Now look at here again. So I'm going into the put method. See, one element, second element, third element. Can I say my queue size is 3 and I have 3 elements? It is full. Now, whenever do I have the place to add the fourth element in the queue? No.
No space.
Then what happens? So what internally this put method will do? It will check what is the size. Yes. What is the current capacity? If both are matching, then it will call the wait method on this queue. So that means the thread went into a wait mode. Now, can I say another thread is also working on the same queue, same object? Yes. Whenever I call the take method, what it will do? It will delete one element. What element? First in, first out, the 0th one, correct? So
Yes.
0 element will be deleted. And then what is the size it will become?
2.
So then, can I say my thread 0 will come back to the execution immediately? Currently, it is stepping. So whenever I do F6, immediately this will come back to the execution. Look at here. See, can I say, see, what is the queue size? Again, 3. How can you see? See, 0 is deleted. Immediately 3 is added because your thread is executing, correct? Look at here. Earlier, thread 0 started coming back to the execution. So what is a blocking thread? So internally, in the thread pool concept, the blocking queue will be used. The reason for that is, so once the thread started executing the work, so it can be dynamically, it should happen, right? You cannot say that my queue is full, my data structure is full, correct? So internally, this put method of a blocking queue follows the wait notify kind of. So whenever, see now, if I execute again, or else what I will do here, let us run the program. Now, what I have done earlier, I started the first adding the elements thread, correct? Now, what I will do, I will call the thread take thread first. Now, look at here. Earlier, I executed this one adding. Now, what I will do, I will call this method. Currently, what is the queue? Queue is empty. So, if you try to poll the try to call the poll method or take method on empty queue, what it should return generally null, correct? But this take method will not return anything. It will now the take method will go into a waiting mode until someone adds the data. Look at here. See, it went into a stepping mode. Why it is stepping mode? Because your queue is empty. Now I'll go to the main thread and I will add the data. See, queue.put. Immediately, thread 1 will come back to the execution because when after adding the data, it is doing notify. So notify means the same thread, one thread which is executing on the same thread will come back to the execution. Look at here. It has taken the data and you can see the output. System.out.println has printed 0. Hope you understand. So this is
Yes.
what the logic that is used internally in the multi-threading. Sorry, whenever you are using executor framework, right? Executor framework internally uses a blocking queue. Why blocking queue? It is, see here, can I say this put method and take method, both are working on a same object. Can I say they are talking to each other using a wait and notify method? inter-thread communication is happening here, correct? So why the executor framework is using internally the blocking thread? Because whenever you have an executor framework, how many threads are there? In the executor framework, how many threads you can create using a new fixed thread pool?
Any number, sir. We can.
Any number. That means, can I say more than one?
Yes.
If you are creating 3 threads, and now 3 threads has to talk to each other to see whether the complete queue is empty, correct? So whenever one thread is, for example, now how someone asked me a question on how the executor frameworks works internally, right? Do you have that person? No, I'm not saying anything. If that question is, I'm answering that question, do we have that person who raised how does the executor frameworks works internally? Okay, if no problem. So here I want to execute 6 tasks. Okay, and I'm creating 3 threads. Now can you say T1 will execute this one, correct? T2 and T3. After completion, this data will be deleted from the queue. Okay, now how does the threads will know that still there is a work? Until the queue is becoming 0, it will execute continuously, correct? And for example, if you add the data again, the thread has to start executing, correct? So internally, if you are using a blocking queue concept, then what happens? Even say if the queue is becoming empty, then these threads will be alive. And when someone submits a task, immediately one of the thread will start coming back to the execution. So that will happen because of this put method and take method. So internally, the thread executor framework uses a blocking queue. What is a blocking queue? Blocking queue will internally create a blocking operations. If your array is full, it will wait for someone to delete. If your array is empty and you're trying to delete, it will wait for someone to insert the data. Now here, if all the queue is completed, then if someone is added before shutting down the thread, someone added the data, immediately thread will start executing. How does it will know? Because whenever you call add a data, I'm like submit a task, it will internally call the put method, and this threads will if the thread is alive, it will call the take. That means from the queue it will take the work. So that's how the thread, these T1, T2, T3 threads will talk to each other and continues the work until the queue is empty. So this is the internal implementation of a executor framework. Any questions? Does it understood what is a producer consumer problem or what is a blocking queue? It's a data structure topic, but I tried to explain this one because internally in the threads, there is a blocking queue is used. Any questions, guys? Silence makes no understood or everyone understood.
Yeah, this is clear, Karthik.
Okay, thank you. So, so tomorrow from tomorrow we will start the questions. We almost completed. There are some topics called thread local, thread groups, optimistic lock, pessimistic lock. We already discussed all of this. And then one more thing called cyclic barrier. All these are simple one, which will be covered during the questions. Now I have prepared some questions, guys. So these are all the interview questions, and there are some interview programs as well. So tomorrow and day after tomorrow, we are going to cover this. So we are going to write the shortcut answers here. What is a thread? Independent path of execution. Anyways, you can refer to the notes, but here we will write, and at the end of the course, I will share this document also with you. So I have written some questions. These questions will go through it. In these questions, we have this one, cyclic barrier, thread local, fork join pool, someone asked a difference between a when to go for a thread and when to go for runnable interface. So all this will be covered in the interview questions. Okay. So we'll take another 2 days to look at. First, tomorrow, what we do is we'll complete maximum of the questions and see the remaining topics. Okay.
Sir, interrupt method is missing, sir.
That is also there. Yesterday I have don't you see this interrupt method?
Okay, sir.
Yeah. I told you that, right? Yesterday, whenever you
Yes,
asked
yes,
me,
sir.
it will be covered in the interview questions. I'll not go anywhere until I cover. Okay.
Yes, Karthik.
So tomorrow and day after tomorrow might be on Friday. I may take, like if time does not permit, I may take another 10 to 15 minutes of time and then I will complete. So by 17, we'll be good to close. So almost we are on top of time within 15 to 20 days. So by Friday, we can close the course. Okay. Now, guys, I will be sharing one Google form link on the feedback. I request you guys to please provide the feedback. Okay. So, and guys, so today I'll not be taking the data structure class. I'll be taking the design pattern. So this will be there for just another 2 days only. So today there is no data structure class. I'll be putting the message in the WhatsApp group. Okay. And there is a design pattern class which will be continued as per the plan at 9 a.m. I'm not able to speak continuously. It's been almost 1.5 hours, right? Again, 1 hour. So continuously 2.5 hours, it would be difficult for me. So only for today, I'm canceling. Okay. Yeah. Thank you, guys. Thanks for joining. Have a nice day.
Thanks, Karthik.
Yeah.
Thank you.